In this tutorial, we're going to look at reacting masses calculations. There are 3 steps to these calculations. Step 1. Calculating the moles of the known substance. This is where you will know the formula of the substance so you can work out the molecular mass, and you will also know the mass of the substance. Step 2. You will then use the mole ratio to determine the moles of the unknown substance. And finally, step 3. You can calculate the mass of the unknown substance. Let's have a look at an example. What mass of lead oxide is produced when 89.3 grams of lead nitrate decomposes? Let's highlight the sections that we do know. Lead oxide is the unknown substance, and that's the formula here, PbO. Lead nitrate is our known substance, PbNO32, and that has a mass of 89.3 grams. Step 1. Moles of lead nitrate. This can be calculated using the mass of lead nitrate and the MR. The mass is 89.3 and the MR is 331.2. This is 0.270 to 3 significant figures. Step 2. We now use the molar ratio in the equation to find the moles of lead oxide. We can see that the moles of PbNO2 is equal to the moles of PbO in the equation. That means the moles of lead oxide that are produced in the reaction is also 0.270. We now rearrange the equation to work out the mass of lead oxide. This is equal to the moles of lead oxide times by the MR. So we have 0.270 times 223.2, which is 60.2 grams. Next question. What mass of oxygen is produced when 136 grams of hydrogen peroxide molecules decompose? In this question, oxygen is the unknown and hydrogen peroxide is the known. Step 1. Moles of hydrogen peroxide. This is calculated using mass divided by MR. As in the previous question, the mass is provided in the question, 136 grams, and you have to calculate the MR using the formula. So 136 divided by 34 equals 4 moles of hydrogen peroxide. Step 2. Moles of oxygen. Again, we can see using the balanced equation, the 2 moles of hydrogen peroxide produce 1 mole of oxygen. Therefore, 4 moles of hydrogen peroxide will produce 2 moles of oxygen. Step 3. Mass of oxygen. This is where we will use mass equals moles times the MR, remembering that oxygen is a diatomic molecule, so 2 times 32 equals 64.0 grams to 3 significant figures. Final example. What mass of hydrogen is produced when 10 grams of aluminium reacts with excess hydrochloric acid? Hydrogen as our unknown, and aluminium is our known substance. Hopefully we're getting the hang of this now. Step 1. Moles of aluminium, calculated using mass over MR. 10 grams of aluminium divided by 27 equals 0.370 moles to 3 significant figures. Step 2. Calculating the moles of hydrogen using the molar ratio, which you can see from the equation. For every 2 moles of aluminium, we get 3 moles of hydrogen. So the moles of hydrogen are determined by dividing the moles of aluminium by 2 and then multiplying by 3, which gives us 0.556 moles. Again, in step 3, we rearrange the equation to work out the mass of hydrogen using moles times MR, which gives us 0.556 times 2, and the answer is 1.11 grams. We hope this tutorial has helped you understand reacting masses a little bit more. Please let your tutor know if there are any other tutorials that you think would help you with your studies.